Hi, everyone from Iceland, where I'm all rugged up and it's past midnight. So I apologize if I look a little bleary. Thank you for inviting me to speak here. It's a real honor. And of course, it feels a bit funny because you all are the experts here and I'm kicking this off. So I'm hoping that, as I tell you about my book and how I wrote it and why, that I can lend a little bit of a different perspective to what you already know, and maybe you might learn a few new tidbits and things like that. So let's start off. So I spent 10 years doing the research and writing to create breath from salt. And you might actually wonder why, because I don't know anyone before writing this book. I didn't know anybody who had this disease. And all I knew about this disease was the basic pattern of inheritance that I had learned in my biology class. But I think the reason that this story spoke to me was that I came to it with other eyes. Um, and while others who have been immersed in the community or the science or the patient care or the fundraising could see only incremental advances, I think I could see the big picture because of two factors. First, I had a science background to appreciate the monumental breakthroughs in medicine. And second, I had the journalist's eye to recognize the hundreds of stories of resilience, grief, tenacity, and heroism on the part of not just the families and people suffering from this disease, but also those working for decades to end it. My interest in CF began as I was writing a short story for Discover magazine back in 2012. And I realized, and this Discover magazine article was about the development of Kaleido. And I realized, pretty quickly as I interviewed Bob Bell, Vertex scientist Eric Olson, parents Rob and Kim Cheevers, whose daughters both have CF, that my feature, this 10-page feature, which, they cut me off at 10 pages for this magazine story, I had barely scratched the surface. When I was talking to Bob Bell, Kaleido had just been approved, and Bob was just bubbling with excitement, describing how there were much better drugs on the horizon that would work for many more people. So he really drew me in, and I became excited about what was going to happen with this disease, with the treatments, with the drugs. When I interviewed Eric Olson, who at the time was one of the scientists leading the CF drug discovery at Vertex, he told me about the connections that he had made with local Boston families and children. And, he broke down telling me that some of these children who he had become very close to, they had died while Vertex was still developing drugs that might have saved their lives. And I was so moved by his passion and his connection to the patients. Um, and and then when it came to developing these drugs, I was fascinated by the fact that there was a drug that worked for only 4% of patients with CF. And that was a mystery to me because, why would a pharmaceutical company dive into drug development for a rare disease and focus on just 4% of those people? So there were all these questions brewing in my mind. I was meeting amazing, amazing people who inspired me and whose passion really moved me. And then when I met Rob and Kim Cheevers, they told me about how their daughter's health had been transformed by these drugs. They didn't need cleanouts, they didn't get sick, they were able to put on weight, which is something they had never been able to do. And this was all because of this one little pill, Kaleido. So I quickly realized that, this wasn't just a magazine story. This was a 70-year epic saga. And I really wanted to be the one to tell it. There was a lot of joy and grief, triumph and failure, and breakthroughs and setbacks. And I knew that it couldn't be, I knew that my journey with CF couldn't end with that magazine piece. Another element that was particularly moving for me was, the heart of this story is a tight-knit community that recognized as early as the 1950s that the only way to cure a rare disease was to raise money, because money buys science and science can yield cures. But the event that really changed my life and made me commit to a book project was my first meeting with Joe and Kathy O'Donnell in Cambridge, Massachusetts, in a boardroom overlooking the Charles River. And, I expected my meeting with Joe and Kathy to be brief, sort of a recap of their fundraising work. But what they shared with me was the most intimate and moving details of their 12 precious years with their son, Joey. They had just met me, but yet they shared the torturous 6-month-long period which Joe and Kathy, through which Joe and Kathy struggled to get a diagnosis for Joey as he became sicker and sicker. And Joey was born in 1974 when diagnosis of CF was still, it was spotty. Some physicians recognized it, but most didn't. They told me about how Joey thrived after the diagnosis and about the relatively healthy 5 years he spent afterwards, and how he grew into a charming little preteen. And, they shared with me the really, really rough times as Joey's health began slipping away. And the O'Donnells took me into a world within that border that Maggie O'Farrell talks about here on this slide. They took me into their world and they shared that world with me in intimate detail, and I was so moved by that. I'm a parent, I'm mother of 2, and there are times when it's been hard, but I have healthy children and I could not believe what they had gone through. So I would like to start off this session by reading a little part of that introduction to the O'Donnells and to Joey, so you can get a sense of what things were like in 1974. 10 days later, on October 20th, Joey was readmitted. Nearly 6 months old now, he only weighed about 8.5 pounds. He was vomiting again. His body was lethargic and floppy. His skin was covered in an ever denser coat of speckles, and he had a raging case of pink eye. Dr. David Walton, a pediatric ophthalmologist, examined and found that Joey's eyes were dry, which left the surface vulnerable to infection. And the clear protecting covering of the eye, the cornea, was cloudy. Joey was looking at the world through a fogged windshield. Dr. Walton suspected a severe lack of vitamin A, the most common cause of blindness worldwide. But after consulting with Kathy, he found there was no shortage of vitamin A-rich foods in Joey's diet. There was, however, another possibility, which Walton knew was linked to such eye problems: an inherited disease, particularly common in New Englanders of Irish descent. Walton suggested that Joey's sweat should be tested. Kathy told him that this had been done already, months earlier, and that the results were normal. But Walton knew that the test was often botched by inexperienced doctors at small hospitals, and he requested it be redone at Mass General. The next day, on October 21st, Kathy was standing by the elevator when a young resident who had been caring for Joey stepped out with the results. The sweat test confirmed Dr. Walter's suspicions. Joey had hypersalty sweat, the resident explained, the hallmark of an inherited and fatal disease called cystic fibrosis. Kathy was terrified. She had never heard of cystic fibrosis and had no idea what the resident was talking about. The hospital's geneticist, the resident said, could tell them much more. It was just after 2 p.m. when Kathy called Joe, sobbing, her trademark Irish stoicism cracking. Joe knew immediately what Kathy was about to say was dire. His wife was congenitally calm. It took a lot to frazzle her. In fact, in the 4 years they had been married, Joe had rarely seen her shed tears. Now she was incoherent. He felt his pulse quicken as he pressed his ear to the receiver, straining to decipher her words through the sobs and the din of the hospital. She was hysterical, and her fear filled him with panic. Cystic what? He asked. He had no idea what she was saying, but he seized upon the one word that he did understand: fatal. He rushed straight out of the office and sped to the hospital where Kathy sat, her face flushed and tear-streaked. Joe held her until they were led into an office of the medical geneticist, where they learned Joey's fate. The geneticist, short with a goatee and dark hair, shook Joe's hand, but barely nodded at Kathy. He reviewed Joey's records and, without making eye contact with either parent, delivered the facts with speed and clinical precision. This is a genetic disease, the doctor said. Everyone carries 2 copies of the gene that, when mutated, causes cystic fibrosis. Each of you carries 1 normal and 1 mutated version of this gene, and you each gave your son a bad copy. He inherited this from both of you, adding, receiving 2 bad copies is lethal. The words sounded garbled and foreign to the O'Donnells, as if the conversation were happening underwater in a inherited? Neither Joe nor Kathy could remember anyone in either family who had died young, and both of them were in great health. They'd never crossed the threshold of a hospital before Joey's birth. The geneticist continued with his rapid-fire monotone primer. Children with this disease have salty skin. They produce thick mucus that clogs the airways and promotes severe bacterial infections that destroy the lungs and lead to death. The life expectancy for children with the disease is 5 years. But, he said, your son's lungs are badly damaged. He probably won't live a year. Then he paused. He probably won't get out of the hospital, and if he does, it won't be for long. Your son's death is going to be long and slow and painful, and you ought to know that. That is a little of what I learned from Joe and Kathy during our first meeting. And for them, that meeting with the geneticist was still as fresh as when it happened in 1974. And I was instantly moved by them and by their story and by the fact that they were so committed to this disease that stole their son. That's something that, blew me away about a lot of parents within the CF community, that, they had endured an unimaginable loss and still they continued to work hard so that others wouldn't experience what they did. So that sort of marked my beginning into this world and the beginning also of the book. So as I was thinking about how to structure the book, I focused on 3 themes or threads and tried to weave them in and out throughout the story. So the first thread was the personal, was the personal stories of the O'Donnells and the other families who battled this disease. But it was very apparent that CF was a disease with an oversized impact in science and medicine. And this was the second thread that I wanted to weave throughout the book. And this didn't just include the science, but the trailblazing scientists who actually made the breakthroughs. And to write this book, I tried to meet as many of these people as possible to learn how they did their experiments, why they studied this disease, and what motivated them. Because this was definitely one of the most fascinating and enjoyable parts of reporting for the book. Now, when most people talk about CF today, the discussion begins with the discovery of the gene. But it was actually a physician named Dorothy Anderson, a largely forgotten character in the history of medicine, who actually characterized the disease back in 1938. She was the first to recognize CF as a distinct disease and recognize that until that point, many patients had been misdiagnosed with celiac disease, which is actually an allergy to gluten that can be cured with a gluten-free diet. She was truly an extraordinary woman for her time. And the second excerpt I'd like to read focuses on her. So take yourselves back to 1938. Cigarette hanging loosely from her lips, pathologist Dorothy Hansine Anderson peered through a veil of smoke at the little girl lying on the metal table in front of her. The barest warmth long absent from her translucent skin, a reminder of her untimely, unnatural death. Anderson had seen this child, whom she labeled MD in her notes, when she first entered the hospital for the first time a year earlier, alive but miserable. Just shy of her second birthday, she had skeletal limbs and a pot belly, a sign that she was malnourished, like African children Anderson had seen in the medical journals, although in this case, it was not due to lack of food. In 1935, Anderson was a rarity in America. Fewer than 5% of practicing physicians were female, and they were strongly encouraged to focus on just pediatrics, obstetrics, gynecology, and housekeeping elements of public health and preventative medicine, although social pressures at the time often dissuaded parents from ever seeing women physicians. But Anderson is special. She was one of an even smaller group of women who held both a medical and a doctoral degree. She was pragmatic and worked tirelessly, married only to her work. She shunned makeup, wore her hair in a tight Victorian bun. She chain smoked, and after hours, she drank pretty hard. She completed her medical degree in 1926 and then taught anatomy for a year at the University of Rochester before applying for a surgical residency, which she was denied, historians believe, because she was a woman. But refusing to be swayed by the social mores of her time and determined to have a career in medicine, Anderson accepted a position as a research assistant in a pathology lab at Columbia University. There, she focused on endocrinology, the study of hormone-secreting glands that orchestrate growth, reproduction, mood, and digestion, and sleep. And in 1935, she received her doctorate in medical science and accepted a job as a pathologist at Baby's Hospital. As a pathologist, Anderson autopsied bodies of patients whose deaths were inexplicable or of academic interest. It was a profession suited to Anderson's solitary nature, and she took pride in the methodical work it required. Once the patients' bodies were delivered by gurney to the hospital's dank bowels where Anderson presided, a highly choreographed autopsy procedure began. There was a specific order for weighing, measuring, cutting, and sectioning the organ. Anderson would take small slivers where the tissue would be dyed, embedded in paraffin wax, and sliced paper thin so that others could examine them under the microscope. But now, in 1936, Anderson had a new mystery case, MD, case number 44. With the child lying on the table, Anderson opened her notebook, arranged her instruments, and began the autopsy. Age at death, 3 years and 1 month. Body pale but well nourished. A bright red slash on her right clavicle where surgeons had corrected her twisted neck. The contour of her chest was normal, a plateau at the chest bone. The belly slightly distended, but greatly improved from a year ago. With a scalpel in hand, she scored the girl's chest and inserted a surgical buzzsaw, grinding away through the sternum. She cracked the breastbone in half and stretched the ribs apart like two halves of a walnut. The heart and aorta, the hose-like vessel that carries the blood to the rest of the body, looked normal. She removed the heart, weighed it, put it aside. She removed the right lung, weighed it, filleted it, opened it like a book. As a pathologist, she'd seen many healthy lungs, spongy, soft, and pink, but this was not one. A healthy lung could be squeezed, chasing pockets of air into other chambers of the organ that then expanded balloon-like. This one was heavy and dense, pocked with dime-sized abscesses that were filled with plugs the color of dried blood or the hue of yellow cheese. Some of the mucus plugs were green instead. The shade, Anderson knew, was dependent on the bacteria living there. The tissue between the abscesses was mottled and tough, incapable of the stretching and relaxing that breath inspired. The bronchial airways were cemented with thick, sticky mucus. The left lung was a little lighter than the right, but when split open, it looked exactly the same. Next, Anderson removed and weighed the soft, bright red spleen. It looked normal. The liver was a pale yellow rather than a reddish brown, but otherwise it was normal as well. The stomach was small, but also normal. Then she lifted it to examine the pancreas nestled below. Something wasn't right. Anderson leaned in for a closer look and then removed the pancreas to place it on the scale. It was just half the expected size. As she inserted her scalpel into the banana pepper-shaped organ, she heard a scraping sound, as if the pancreas itself were filled with grit. The healthy pancreas is an unsung gland sitting discreetly in the abdomen, shielded by the liver and stomach, quietly secreting various juices. Some of its cells make insulin, a hormone vital for lowering sugar levels in the bloodstream, while others make a hormone called glucagon, which increases blood sugar when the body needs energy. Others churn out acidic digestive juices, without which the intestine cannot break down food and extract nutrients. Most of MD's pancreas, in contrast, was filled with fibrous cysts, something Anderson had never seen before. And it had only a few remaining insulin-producing cells. In a healthy pancreas, a long central tube called the pancreatic duct runs the length of the organ, collecting digestive fluids and passing them into the bile duct, which empties into the intestine. But when Anderson searched for MD's pancreatic duct, she could only find a short half-inch section. The rest of the pipe, if it had existed, was lost in a mass of tough scar tissue. It was clear that this organ couldn't possibly have been doing its job. That explained the patient's malnutrition. But Anderson had never seen a celiac patient with a pancreas that was so damaged. She began combing the medical journals for clues, spending all her free time hunting through stacks of books and journals in nearby Columbia University's library for mention of similar cases, and exploring autopsy files of other children who had been diagnosed with celiac disease. She soon discovered reports to Europe, to Australia, describing similarly fibrous pancreatic cysts in other children who had been classified as celiac patients. But she knew that kids with celiac disease, once they were prescribed the right diet, didn't usually die. They grew quite normally. Perhaps MD didn't have celiac disease at all. In fact, based on the state of her pancreas, her cystic fibrotic pancreas, she was fairly sure she didn't. Surrounded by an ocean of medical literature in Columbia's library, Anderson realized that this could be an entirely new disease, one that, unlike celiac disease, was incredibly deadly. So I hope that somewhat long excerpt from the Dorothy Anderson book gives you some insight into this amazing woman who was just not given enough credit at the time. Unfortunately, I didn't get to meet Dorothy Anderson. She died in the early 60s from lung cancer, which wasn't a big surprise because she was a big chain smoker. But, when I began to write this book, it was a priority to meet the scientists that had major breakthroughs. And because, with Dorothy Anderson, I learned about her by digging through the archives at Columbia University to find out, to see her personal letters and a lot of the stuff from her lab. But, I wanted to meet people. So I actually had the pleasure of meeting Paul Quinton, and you see him here. This is a photograph I took when I visited his lab. And Paul Quinton and another team on the East Coast figured out the defect in the cell that causes the salt imbalance in the body and triggers all the various symptoms of cystic fibrosis. And my day in the lab and having lunch with Paul was riveting. He explained to me what it was like to live with CF in the 40s and the 50s, when few physicians really knew about this disease. And it was it was even more thrilling to hear about how he diagnosed himself with this disease and then spent the next 20 years figuring out how his cells were misbehaving. In fact, Paul gouged out chunks of his own flesh to figure out why his sweat glands excreted saltier sweat than other people without this disease. And it was because of his work that, it laid the foundation for the gene hunt, which came soon after. I had the pleasure of meeting many of the members of the team who discovered the CF gene. Lapchi Choi, Bathsheba Karem, Joanna Ramans, Dr. Francis Collins, Jack Reardon. I got to speak with all of them and hear the drama. And the drama lasted almost a decade, from 1981, when Lapchi Choi started studying this disease, all the way through 1989, when they finally got the gene. I spent time with Ron Crystal and Jerry McIlvaney, who performed the first CF gene therapy trials in humans after the gene was discovered. And this is interesting because, CF has so many firsts that I don't think are appreciated by maybe some of the younger members of the community. This was one of the first disease genes discovered in the 80s. It was one of the first diseases where they tried to fix the disease with gene therapy, because it was believed, and it's true, that if you can replace a broken gene with a healthy one, then theoretically you can fix the disease. Of course, in the early 90s, they've discovered that this was a lot harder to do when you needed to change and replace a gene in the lungs. So although they proved on a very tiny scale that it could work, it didn't produce any therapeutic benefit. So that approach was abandoned. CF is also one of the first diseases to have a gene test for prenatal screening. And this is where the story starts to fold in on itself, and the threads that I told you about in the beginning of this talk start to merge, because the O'Donnells, who lost Joey in 1986, were able to use genetic testing to have two healthy daughters shortly after. And in this photograph, you can see Kate and Casey O'Donnell. And Casey now has two healthy children of her own. And, they used genetic testing there to make sure that neither of the children would be ill. Now, I've told you a lot about the science, which of course you already knew, but I hope you got some fun insights into some of the characters who developed that science and made those discoveries. But, when I was doing my research for this book, I looked at all this science, this path-breaking science. I mean, people were looking at CF to figure out how to crack other diseases, to find other disease genes, to do gene therapy. And I wondered where all the support for this research, this path-breaking research actually came from, because this was a rare disease after all. And that's when I started to learn the backstory of how the Cystic Fibrosis Foundation had grown from just a handful of parents to a fundraising powerhouse. Today, it's just a few notches below the Bill and Melinda Gates juggernaut. So how on earth did this tiny foundation back in 1955 fund and finance such impressive science? And the answer, the answer is with a lot of fundraising, a robust and multi-tiered fundraising effort. And describing the formation and the growth of the foundation and their strategy for funding science, this became the third thread of the book, because you need money to fund science, and it takes a lot of money. And the government wasn't willing to provide the science and the funding for it that was needed to crack the cause of cystic fibrosis. And that's where the leaders of the Cystic Fibrosis Foundation stepped in. And here you'll see Bob Dressing and Doris Tulson. And many of the strategies are things that they actually created themselves. In the 1950s and early 60s, they recognized that it was important to fund science and not publicity for the disease. They also emphasized that patients needed to participate in medical research if they actually wanted to benefit from cures, because there was no other population that could serve in various clinical trials. And another thing that was revolutionary that many health nonprofits are now following is that they created a data registry to log the characteristics of the patient and the symptoms that those patients suffered, because this disease has such a broad spectrum of characteristics that, they wanted to start matching up patients with symptoms. And the database was very simple when it started in the 60s. And now, I'm sure you've all seen how complex those reports are, how granular they are. And all of these things together, the funding, encouraging patients to participate in medical research, and creating a data registry, all of these were essential elements to actually developing medications and drugs decades later. And the way they came up with this approach, it actually wasn't just their idea. They learned how to do this from Franklin Delano Roosevelt's polio czar, Basil O'Connor, who led the effort to fund and develop polio vaccines in the 1940s and 50s. So Doris, who came from a fairly affluent family, very well-connected family, met with Basil O'Connor and learned sort of the secret sauce to finding the cause of the disease and developing treatments. And he sort of gave her the playbook on how to raise money, who to fund, how to figure out who to fund, and how to keep the science on track. So she sort of learned from the polio czar himself and applied many of those lessons to cystic fibrosis. And so the Cystic Fibrosis Foundation was the first health nonprofit to invest in pharmaceutical companies and use that early funding to guide R&D that eventually led to the drugs that we have today. And this philanthropy-funded science eventually became known as venture philanthropy. And venture philanthropy began after the failure of gene therapy in the 90s. So at that point, Paul Quinton had figured out, what's the defect in the cell. Then the gene was discovered. Then they tried using gene therapy, which everybody was convinced was going to fix this disease, cure this disease. And when it failed, the leaders of the Cystic Fibrosis Foundation Bob Bell and Preston Campbell, they realized that if they wanted a drug, if they wanted to find a cure for this disease, they had to go out and invest in pharmaceutical companies and get those pharma companies to work on designing a drug. And it was their idea. Venture philanthropy was really their idea. And from that emerged first Pulmozyme, and then Toby, and then Kaleido. And then you know the rest of the story, which was the development of 3 more drugs that to date, you know, target the root of this disease and treat more than 90% of patients. And I had a wonderful opportunity there too to go and visit Vertex several times, talk to their scientists who really inspired sort of the last section of this book. And they were very generous with their time and told me, you know, the backstory to their work on these drugs, the sort of artisanal chemistry that went into building these drugs, molecule or atom by atom, and coming up with these life-saving molecules. And today, what really is astounding is that the royalties that the foundation received after selling the licensing to these drugs generated billions. And those billions are now being used to fund more research in more than 100 labs worldwide, as well as dozens of drugs and treatments that are in the pipeline that will be used to find a treatment for that 5 to 10% of patients who are not helped by the modulators. So I didn't know the ending of this story when I wrote the book or when I started writing the book. And I was lucky because the science kept moving forward, and I kept chasing it and writing. And in the end, it was a 500-page book, which nobody really expected, and least of all me. But, you know, by the time I finish this book, I'm filled with great hope and optimism. And I'm optimistic that, you know, going forward, there will be treatments and cures for the 5 to 10% who don't have anything now. And eventually, I really do believe, after watching the science progress over the last, I would say 20 years, that, you know, we are going to see something miraculous and equally transformative in the future for the rest of the patients and the whole community. You know, this is, after all, the quest for a cure, not just a treatment or a drug. And I also have great optimism that, you know, other diseases, rare and common, will be able to use some of the strategies the CF Foundation pioneered to find treatments and cures for other diseases. So with that, I want to thank you very much for inviting me to talk here. And I hope you've enjoyed some of the little character portraits of people in this book. And I'd be happy to stay on for the panel discussion. So thank you very much for having me. And I look forward to your questions.